Hello, Tyler Wasilenko here. Thanks for joining me on this short little video on how to configure a UT55A controller using Yokogawa's setting tool software program. This will give you a general idea of how to configure your controller using the laptop and the Yokogawa modem cable connected to the controller. So we're going to start out by going into our start menu and finding ourselves the setting tool software, which is represented by a small icon that looks like the front of the controller. So let's open up the setting tool, and we start out with the pop-up window here, startup guide, and we want to select new with wizard. So we'll click OK. First screen that pops up here is the system data screen, which allows us to input the particulars for the controller series that we are dealing with. In this case, we're using a UT55A, which is part of the UT50A series. Basically all the settings here are fairly standard. We do make one change, which isn't necessary at this point in time, but we'll do it anyway because in future labs you'll have to. We just change this type 2 function to a 4. Some of the other things that we can do on this particular screen here is select our control mode. We have selections here for single loop, cascade, bumpless transfer, PV switching, PV select, and a couple of other ones. We are concerned at this point with just a single loop control, so we're going to leave it on single. Now we can click to close out of this screen, and it now gets us into our parameter setting window. So we'll set up some of the basic parameters here for a milliamp input and a milliamp output, which basically is mirroring the first lab that was done when all these parameters were set using the buttons on the front of the controller. As we go through the menu here, we just are taking steps down the menu tree here and filling in the blanks as required. So there'll be a lot of them that we're not going to use. So unless I say to change something, just leave them as they are defaulted. So control type here is set currently at PID, which is what we're going to use, but just to show you, there are a couple of other choices: on-off control, batch, feed forward, and such, but we're going to stick with PID and press next. Here's our PV screen, where we're going to select what our PV input type is. For this lab we're going to do milliamps, so we'll scroll down through the multitude of selections here, all different types of thermocouples and RTDs and other types of inputs, and we're looking for the 4 to 20 milliamp one, which is down here, and we'll click on that. And underneath it, our PV input unit, currently here set to degrees Celsius, we're going to change that to no units. So what we see now on the screen here is our maximum input PV is 20, representing 20 milliamps, the minimum PV here 4, representing 4 milliamps, and our scaling, which is set up as 0 to 100 right now. I like to leave them all set at 0 to 100 just for ease of demonstration, but you could put in whatever your measuring range might be, 50 to 200 degrees Celsius, or if you're measuring level, you could put in inches of water column in there, whatever suits you. But for ease of demonstration, we're going to leave it at 0 to 100 here. Click next. Remote set point tab here we are not using, so we'll just skip through that by pressing next. Here's our output selection. Currently set to output 3. You see our choices are either off, voltage pulse output, current output, or relay output. We're going to do milliamp output, so we'll select current, and that's all that we have to change here. Select next. Nothing in the key menu, nothing to change here in the display menu, nothing to change in the digital input menu, nothing to change here in the system menu, and also nothing in the level menu. So we just blow through all of those ones quickly and move on. So you'll see now we have changed over to a different menu tree here. This one is operation parameters. We can toggle back and forth between setup and operation parameters using the tabs down here on the bottom. One thing to tell you about is if you're going to try to go back into your setup parameters and change something, you'll get a message, or I thought you would, I guess I lied. You'd usually get a message asking you if you want to accept the changes, and that's fine. So we'll carry on here with our operation parameters. We're not worried about setting up alarms at this point in time, but if we were, this would be the screen that we went to set the different alarms. Set point for loop 1, that's what the L1 means here, and this controller can store up to 8 different loops, but we only are going to use one set of settings at this point in time. So if we wanted to change our target set point, we can do that here by clicking on the field and entering a value of whatever you desire. This is also very easily set from the control panel on the front of the controller as well, so no need to worry about that. Set point ramping is not what we're something that we're worried about here, so we're not going to touch that. Same with the PV input bias, not worried about that. The next one that we look at here is PID, and we will be using this. This is where we set our different values for our proportional, integral, and derivative. Again, proportional band in the case of this controller versus gain, which we often talk about in class. So you'll have to remember to do your conversions to get your gain. Integral time here is in seconds, and we're going to just turn that off. And we are also going to turn off our derivative, just like we did in the lab where we were using the keypads. Select next. The next window here is the tune for loop 1, and we're not worried about that at all, so we're going to press next as well. That is the basic setup for milliamp input, milliamp output. As far as all the parameters that are required in order to make it work, at this point it asks, do you want to save the parameter settings? We're going to say yes, and it's going to ask us to give it some type of a name. I recommend keeping it fairly simple, and I'm just going to reuse a file name that I've already got here. So basic milliamps and your name, in this case it's my name, and then save it. Next window asks us if we want to download it to the unit. Of course we want to download it to the unit, otherwise it's not going to do anything for us. So let's download to the unit. And now it is trying to establish a communication link between the software and the hardware. So it'll take a couple of seconds, and we should get a status here. Communication error has occurred. Check the communications conditions. And this is a common error, and it usually has something to do with our COM settings here. You'll see that I have a couple of choices, COM 1 or COM 4. So if you find that you get that message, try a different COM port, hit connect, and you'll see now that we're online. It tells us we're talking to a UT55A 040100. This 4 is that 4 that we changed on our very first screen, and it tells us just general information. There's really nothing here to worry about. Once it has communication established, we can hit the download all button. It'll say, do you want to download basic milliamps Tyler to the controller? And you say, sure I do. We got a parameter version mismatch, which is not significant here. Do we want to continue the process? Yes, we do. So it wrote the information to the controller. The download is now complete. We can press OK and close the setting data. So that's it. That's how easy it is to set up the parameters using the UT55A setting tool. This will correspond with the lab write-up that you guys will have once we get downstairs into the lab. So hopefully having seen this video will help you navigate through the lab package a little bit easier. And I hope you guys have fun.